So the big takeaway for me would be definitely having a defined troubleshooting process that's also universal. So like everyone mentioned, it's cross-discipline. Because a lot of times you don't know where to start when you're going to a problem. So it really cuts down on how long it would take to troubleshoot something. You're more efficient. And also, one of the personal takeaways for me was like having a broad knowledge base. Because even if you don't specify in that field, you'll have an idea where to start, and then you can continue with referencing different departments.
Very, very important.
On of fundamentals, I believe college teaches you a lot of theory, not practice. So I like how this class connected theory, like you said, you started with the fundamentals, what we needed to know, and then how you drove that into how that applies into real case situations. So I think it bridges the gap between just working with equations, doing like, typical textbook, just plug and chug and this actually takes you from the fundamentals, how we can apply them in our everyday job, and getting that bits of pieces of the different disciplines I felt was essential. Because like even with our roles, for example, I'm strategic, but I'm strategic mechanical. We have strategic electrical. So this kind of helps you steer away from blind trust, because blind trust is mostly dependent when you don't have the knowledge to be like, you know what, you're actually kind of wrong. So having just a basic understanding of the most essential topics would be like, if you're doing in a group, someone spits out an idea, you can refute it if you have background, because you don't know anything, you're just gonna be like,
you're taking whatever he says, right?
Yeah, so I think just having the overall picture is very essential. That way you can, like I said, refute anything that you don't believe is correct, have better understanding of how your system works. Because Jessica touched upon it, we all focus on the problems within our own kind of specialty. We don't, as myself, I don't know as much, or I didn't know as much of the other disciplines to actually think, oh, this could be a failure factor. But being able to see the full picture, you can actually pinpoint things that are outside your expertise.
Right, you pick up a very important point. To be a good troubleshooter, you have to have all-three. You cannot have just one. And we're in the center as a system engineer or strategic engineer to understand how all three. Even though we don't use it all the time with the other disciplines, we can always ask questions. And oftentimes that's enough. You'll be able to ask questions. If somebody else has to answer, then oftentimes you can find out the problem just by asking questions. Thank you very much.
Kind of running off of what Jessica was saying, just the amount of mechanical failures that kind of lead to electrical failures, like having a certain amount of friction between two mechanical things that create a charge that can short out something else, or having this chemical reaction with a silver sulfide on a contact, and then you get a bunch of extra arcane that you don't need, or you fail that contact. I think that was kind of a big thing for me, and then kind of just putting it all together and getting a really good refresh and a lot of important basic physics equations was huge. I think, it was a lot of really good information. I appreciate you coming here.
You mentioned the one important point, I think, that I want you to key on is the physical equation, all the fundamentals. You see, throughout the class, I always start with fundamentals first. And those are things that actually are basis. Because with the fundamentals, you can extrapolate different places. But if we don't know the fundamentals, oftentimes, all we learn is just basic things. You couldn't put together, you couldn't extend, because we only know one phenomenon. But once you know fundamentals, for example, Ampere law, the Faraday, the Lorentz, then you can extend. And that's the power of I call it college study, right? We pay so much money for it. It's those fundamental knowledge. It doesn't look, spectacular. How big is the Faraday equation? But it explains a lot of stuff. So I want you to key on your point is to remember all the fundamentals we teach in this class. They always use it, and because those fundamentals help you to go to another level. Okay. So thank you very much for that point.
I think for me, it has to do with the electrical failures, like everything electrical. So before this class, I was aware of a good amount of mechanical failures, right? Learning, going more in depth on these electrical failures really opened up my mind to, other possibilities for, wear and, troubleshooting errors. And another thing I realized throughout this whole course was the several stories that you've mentioned, how important operating experiences in terms of troubleshooting and knowing what happened in the past and using that to, using that in the present to, troubleshoot a problem. I realized, from when I started to after this class, how important operating experience is. And thank you.
Yeah, thank you very much. And one thing in my life, with my company, we have 100 people collecting data. So I use this computer called KALE, Constant Search for Data, is because we'll collect about 80,000 data points from France, Germany, Japan, China, US, all in one. Okay, so if you need a database, call me. I will find it. Even I don't know it, I will find the data for you. I will find a case for you. If it happened here, gotta be happened in somewhere before. If it happened in somewhere before, I have a database. So there's 100 people constant input data for me. So use me as sounding board. If you have any, say, well, this one is really weird. I never, really couldn't figure out what's going on. Email me. I will find it and show it to you. Okay. Thank you very much.
I think just like connecting how all the failure modes that you have, that it'll be a mechanical failure with an electrical symptom, isn't something I really had ever thought about before when I started troubleshooting, just because I only have an electrical background. I would just go straight into that, but instead looking at like the ways that the mechanical components can degrade and then seeing how that can lead into the electrical components and some of the I&C components, I think it just like ties everything together for me to give me a background in areas that I wasn't familiar with previously.
Great. Right now you have a whole picture.
Yeah.
Because when we go to a diagnostic, we don't even know which area at the end, right? Could be at the end will be ISC failure. But at the beginning, we don't know. So with the whole picture, you can pull the expert in if you need it. But you don't lose the big picture. You can always find where it is. So I think that's what you probably alluded to, is the power. That's the power of being a troubleshooter. Thank you very much. You picked that on that.